Welcome everyone. In this video I'm going to talk about my new digital microscope, which is a Tomlov 7-inch digital microscope with a 7-inch display. According to the datasheet, you can go up to 1200 times magnification with this thing, and the video and the camera capabilities are really nice. So you can take 12 or 16 megapixel images, so you can go high up with the resolution, but I think that these are extrapolated images, so the native resolution of the sensor is much smaller. And then the video resolution is 1080p, so basically full HD videos can be made with this thing. And then it has a few parts, and I also made a custom part for this, which I explain later why I did this and why it is a cool thing, which you should also have. And yeah, let's go through these things. So this is a Tomlov camera. You can actually buy it in different brand names. If you buy the Tomlov brand name like this is the TM-DM9 unit. And yeah, it's quite a flexible camera. So let's start with the stand. And here I will highlight you something, a huge mistake that I did. So this is the stand. And this is a part which should stay with the stand, and I will talk about it in a minute. But from a side view, you can see that we have a metal base here, and then there is a rail with some kind of, not gears, but some teeth here. So by turning this knob, I can move up and down with the camera. The camera is mounted in this ring. And then we have two fill lights with this kind of gooseneck thingies, and basically this is the stand plus this box, which should be here at the bottom, where now we have the exposed cables. And the mistake I did is that initially I just had this rail and tried to screw it in without this nut here, and this nut is a tensioner nut and also a spacer, so it doesn't let this rail to, let's say, come out from the plane of the bottom of the plate. Therefore, it also hinders this rail here to touch this board, because apparently this board has the electronics in a very stupid way, that it has everything, all the, let's say, vital parts in the center right under this thing. So if the user makes the mistake that I did, and forgets to add this nut here, then you will exactly hit these 5 components and basically just grind them off from the surface of the printed circuit board. So this is what I did, and this board should be used to power the two LEDs and also have an adjustment here with the potentiometer, so you could adjust the light, the brightness of these LEDs, but currently I cannot do it. But I will make a new box, and I will have like a standalone tiny box with a USB power supply to replace this box. But I think to some extent this is a stupid design, but please don't make the same mistake I did. Always make sure that you have this spacer if you decide to buy this camera for some reason. And you should actually, because it's a nice camera. So this is the stand. It's a sturdy stand, but I think it has this, let's say, design error. And then let's talk about the remote controller. So you can start and stop recording videos. You can take a picture, you can navigate in the menu, you can view the pictures that you took, and so on. And it has 2 connections. So one is for powering the stuff, USB power, and then we have the jack plug as well. So it's a very simple remote controller, but it's very good because if you are at high magnification, all tiny movements can blur your image and shake everything. So it's good that you can remotely control your display and you don't have to touch anything. And then we have this kind of reflector, sort of reflector. So this comes at the bottom of the camera. So now we have this plastic plug, and this is how it looks if I remove this plastic cup. So we have 8 LEDs So they are the sort of fill lights for the camera, and obviously the optics is underneath this conical stuff here. So either we use this plastic, I don't know how to call this, tube, or we use this reflector. And then this reflector has two purposes. One is that it sort of reflects some light, so we can see more when we are soldering stuff, for example. But it also allows you to go more closer to the optics, because this thing sticks out more. So if I put them next to each other, you save like more than 1 centimeter distance. So you can go closer, so you can have a bit better pictures. So before talking about this part, let's see how this display looks like. So this is the display, as you can see. So 7-inch in diameter, or in the diagonal. On this side we have an up button, an OK button, and the down button. This is for navigating in the menu. And then on this side we have a camera button. This is for taking a picture or starting the video or stopping the video. An M for the menu, so we can enter the menu. And then we have the on-off button. And then obviously this gray dial is used for focusing on the subject. And then on this side, starting from the top, we have the USB power and also the USB connection. So this is the connection that you have to use to connect this camera to your computer, because apparently you can use this with your computer, and you can use the default camera software for Windows, but I could not have the native resolution so far, so I have to test different things. But at least it works on computer, so you can have this attached to your PC. So I want to stop here for a moment because I want to show you the camera through the computer. So now the camera is connected to my computer via USB, and I'm using a software called High View, which is able to capture the image of the microscope and then show it. But unfortunately, as you can see here, the resolution is not the full HD resolution, but as you can see, the image looks okay. And what we can see here on the image is some kind of circuitry, and this device, or this part component, is the TCD1304 linear CCD. This is the electronics part of it, and actually here you can see the wire bondings which go from the substrate to the pins of the IC, to the packaging. So this is quite a large magnification. Unfortunately, I haven't calibrated my microscope, so I don't know what distance is between the legs, for example, and so on. But you can see that this is quite a large magnification. And the image quality is more or less acceptable. It is a bit noisy, it is a bit pixely, but we can see what we want to see. And just for fun, we can either have this, for example. So this is some kind of digital zoom, but you can see nicely that now we have like extremely high magnification, and we don't really need this as like regular people. So I think that the capabilities of this microscope and software is perfectly enough for us. So it creates very nice image. And just for fun, I put another component under the microscope, an STM32 microcontroller, just to see how it looks. So I want to highlight this part. This is the LED, the PC13 LED on the board, and you can even see the small wires which go to the LED inside the casing. So this is extremely nice image, and I will try to manually move this board just to look at the other LED. So it's really nice. And then these are just some soldered joints, and we have some kind of component here. This is the crystal oscillator. You can see the 8 megahertz. I will try to focus it. You can even see the markings of the tool which was used to make the writing, and I'm not entirely sure, but probably these are grain boundaries on the metal surface. I cannot really see it with this kind of microscope, but I pretty much believe that we can see the grain boundaries and also the individual grains. So quite nice magnification. And then this will be the side of the microcontroller. You can see the dirt, small kind of fibers or whatever, probably when it was cleaned. This remained there. So let's see. These are the jumper headers, and then you can see the flux residue, and you can see the depth of field is quite shallow, so I have to be very careful with the focusing, because now this is the jumper pin which goes through the board, through this hole. This is the very top of it, and then I can like go through the solder blob very carefully and then reach the surface. And then this is the flux, this is the silk screen, so we can see everything. This is the boot 0 text, and yeah. But as you can see, it's really nice, and we can see the traces very nicely. So I think this camera is more than satisfying for hobby users. It's just, I think it's gorgeous. And I think I could further improve the image quality a little bit by allowing more light to the microscope, because now I'm just using the 8 LEDs, which is at the end of the lens, but nothing else. So maybe with more light we could get a bit less noise, and that would lead to a much better image quality. But I think this is satisfying. For general observations, it's perfectly nice. So yeah, this was the computer view. So this is what you can capture with the computer, but maybe there are better software which can really get the full HD picture from the camera, but I think for us it's more than enough. So let's see the other features of the camera. And then this TF is an SD card slot, micro SD, and this camera actually came with a 32 GB of memory or SD card. That's really nice. So you can record the pictures and the videos on this card and then transfer it to your computer. And then this key is a jack plug that is used for the remote controller. And finally, there is a potentiometer here, which is used to adjust the brightness of these LEDs. And basically that's all. And additionally, I cannot open this right now, or try to. Yeah, you can see that there is a battery here. So actually you can drive this unit for a while without any kind of power source. So you can turn on the camera and use it, yeah, outside your house. But of course, if you have a beefy power bank, you can power it through USB. And then we have this final part, which might resemble to this thing, as you can see. And I tell you why I did this. So this rail obviously has a limited distance while it can come up. So I show it to you from side view. This is about 13 centimeters until the bottom of this. So the gap here is 13 centimeters, but obviously when you attach the camera, that becomes much less. And now the problem is the following. I bought this camera to make SMD soldering mostly, and I want to use this tiny guy, this reflow station with the nice surface. So obviously I want to put this thing under the microscope, right? So the problem here is that now you can see that we lost a lot of distance between the end of the camera and the top of the surface here. To show it more precisely, you can see that the gap is not too much. If I try to measure it just roughly, then the distance between the end of the camera, so here, and the top of this is just, it is less than 3.5 centimeters, which is not enough. Because I cannot cover a large enough area with the camera. So basically I cannot increase the working distance by using this stand. So now how I record this video right here is that there is a camera up here, and then that camera is attached to a sort of a microphone arm and I can move that arm up and down, left, right, whatever. It is connected to a ball head tripod attachment. So yeah, I can do anything with it. I can position it however I want. And the camera is an action camera up here, and it has the same kind of attachment. So I'm using the case of the camera to hold the camera, and the case has a GoPro attachment, but this is a DJI camera. And then this goes to a normal tripod mount, as you can see. So now I made this, and what I can do with this is it snugly fits, as you can see, on this part of the microscope camera. And now I can use this in the same way as my overhead camera, so it becomes an overhead microscope. So I can look at the display, and I can also increase the distance however I want, and put anything under the lens. So I can put the soldering station here, and I can have sufficient distance so I can cover this 3 by 3 centimeters properly with the field of view of the camera. So I will actually share the 3D file of this thing, and as you can see, it perfectly matches this GoPro compatible mount, and it's sturdy, and it even has a hole here, as you can see probably here. So if this fit would not be snug enough for you, but it is snug enough, believe me, it doesn't come off, then you can also add a M5 bolt here and just fix it like in the same way as we have these two fixing bolts here. So yeah, I have this. So I will actually now switch to the camera of this, and I will just show you some cool pictures and talk about the capabilities of this camera. And then we will see what kind of images we can take and what kind of videos we can record with this thing. So now we have this field of view, and you can see that from the left to the right we cover 3 centimeters roughly, but now the working distance, so the distance between the end of the lens and the subject there, is about 15 centimeters. So we are high up, and actually I cannot do this kind of distance with the original stand. So it's nice to have this kind of extension and use it with the camera. And I'm looking at the display. On the display it looks fine. It's perfectly fine for working with this microscope. So what I'm planning now is that we will look at different things. Like I have some kind of scale, which I will just put it. I will just put it here. This is some kind of calibration stuff. As you can see, it's written on it. It's a bit shiny because of the camera, but we will see. So there is nothing else that if you take a picture, you can obviously measure the distance between the let's say the two lines, and then you can calibrate your camera with that. But yeah, there is nothing else. And I guess then also the line thickness can be calibrated, so you can have let's say a pixel equivalent of this 0.4 millimeter width, and so on. So that is a nice thing. But this is just a piece of plastic, so I'm not sure about its precision, but for our purposes, for our hobby purposes, it's perfect. I think it's enough. And then I will look at my destroyed board. You can see it here. Maybe it should not be upside down. So now, as you can see, the pads are pretty much destroyed, and some of the parts like this R1, R3 and Q1 is removed. But you can see that we can record really nicely with this camera. You can see the cables here, which I just cut, and then they are surrounded by some hot glue here. And then you can see the traces very nicely, and you can see these holes. This is the top of one of the screws Then this is the potentiometer, the USB connector, and basically this is all. So you can see everything nicely. So now what I will do, I will move the camera closer to the subject, and we will look at something else just to see what this camera is capable of. So now I have to be very careful, because if I put my hands on the table, you will see that the image goes out of focus, because now the table will bend. So now I just put my hands on the table, both arms basically. Now I remove. So I will be careful. But this is a side of a chip, a back controller chip. As you can see, the manufacturer removed the marking of the chip, so we cannot really know from this board here. And then here we have a resistor, a capacitor, probably a diode, I'm not sure, another capacitor, and let's see what else we can see. Yeah, it's just some markings of my removal attempt. These are the pins of a MOSFET, I see, but of course this is the back side of the board. And then I don't know these pins and their origins. What else should we look at this? Yeah, we have another IC here. Obviously it's a bit out of focus, but I can play with the distance, so you can see that when it is in focus it looks really nice. But of course the depth of field is very, very tiny. So I'm just moving a few millimeters, and then it goes in and out. So now the chip is in focus right now, and now it's out of focus, and I just moved like 2-3 millimeters. But as you can see, this thing can provide very nice images, and you can see everything very nicely. This is basically this marking in the center of the image. I made it with a permanent marker, and you can even see the irregularities of the ink. So it shows everything very nicely. What else should we look at? So this is I think it's a shunt resistor. It's quite large, but you can see all its tiny details. So I think it's pretty amazing. You can even see how the legs of the components were snipped. So I think that's also nice. So now still let's look at something else just to see the but still I want to look at some more stuff just to show you what this camera is capable of. So then one more thing that I would like to show you is the surface of a strain gauge. So here you can see the two solder tabs. I'm trying to point at it with the small tweezer. You can see the ugly soldering, and then you can see the traces very nicely. So this thing is not sensitive in the Y direction, this direction, because you just open up the distance between the wires, but then you elongate or compress the wires in the X direction, this direction, so it is sensitive in that direction, because you change the resistance of the tracks by changing their lengths. So this looks very nice, and I will try to put the scale next to this, or on this. You can see that this is not a big distance. So it's approximately 4 millimeters in width. So as you can see, this is a pretty cool camera. It can do the job very well. Of course, it's not a very good camera, but it's good enough for hobby users like me. I can see at least what I'm doing when I'm doing like small soldering, or I'm trying to manipulate something, a small wire, and so on and so on. So it works very well. I recommend you to visit my website, link is in the description, because I have this attachment there. I shared it as a 3D file, so you can print it for yourself for this specific camera, and you can use it. I think it's a very good thing to use this camera on this kind of microphone arms, because it really helps, and it really makes the work more easy. So I hope you like this video. I hope you learned something, and see you in the next video.